Let us derive the expression for damping factor zeta. So zeta is defined as the ratio of damping coefficient to the critical damping coefficient. So it is C upon Cc for a linear system, and for a torsional system it is Ct upon Cct. So let us see the derivation part of this. So for a linear system, we have already seen that Cc is equal to 2 root km or 2m omega n. Now zeta is equal to C upon Cc. So you can substitute 2 root km or 2m omega n in place of this Cc. So C upon 2 root km or C upon 2m omega n. Similarly, for a torsional system, it is CCT is equal to 2 root KTI or 2I omega n. So here also we can say that zeta is equal to Ct upon CCT. So in place of this CCT, you can substitute this particular value, either of this particular value, depending upon the data which is given in the example. So in place of CCT, it is 2 square root of KTI or 2I omega n. Now we have to do some mathematical adjustment over here. So zeta is equal to C upon 2 square root of km, squaring both the sides. So zeta square will be equal to C square upon 4. This square root will go, so 4k multiplied by m in the denominator. If you take the reciprocal of this term, then it will be 1 upon zeta square, that is equal to reciprocal of this term also, that is 4km divided by c square. Also we are having the another expression, that is zeta is also equal to C upon 2m omega n. So we can say that if you cross multiply by this omega n over here, then it will be only C upon 2m that will remain. So these two terms, they are important for us for the further derivation, and therefore we have taken into consideration the, or rather we have derived this particular form so that we can easily substitute it in the expressions of S1 and S2 which we have already seen. So we have to go back to the values of S1 and S2 which we have already derived in linear damping or viscous damping. So this is the continuation part of that particular derivation. So S1 which we have derived is C upon 2m in bracket minus 1 plus square root of 1 minus 4km divided by c square. So now we are having various values with us, so we can substitute those values. So S1 and S2, these are the formulas which we have already derived. Now we can substitute that in place of C upon 2m it is zeta omega n, and in place of 4km upon c square it is 1 upon zeta square. Similarly for S2 also, in place of C upon 2m we have substituted zeta omega n, and in place of 4km divided by c square it is 1 minus 1 upon zeta square. So now this S1 is equal to, so this is S1 zeta omega n minus 1 plus cross multiply by the zeta square, so it is zeta square minus 1 divided by zeta square. So this is S1 which we have replaced. So here cross multiply by this zeta square over here. So it is zeta square multiplied by 1, that is zeta square minus 1 upon zeta square. Square root of zeta square is zeta. So in the numerator we are having square root of zeta square minus 1. So S1 will be equal to, so we are considering only this part of S1. Similarly you can do for S2 also. So zeta omega n as it is. Now minus 1 into zeta, that is minus zeta, plus zeta square minus 1 whole divided by zeta. Now you can cancel out the zeta term from this numerator as well as from the denominator. So we can say that S1 is equal to omega n in bracket minus zeta plus square root of zeta square minus 1. Similarly, S2 will be equal to omega n minus zeta. In place of plus sign, you have to just substitute the minus sign. So these are the values of S1 and S2 which are now expressed in terms of zeta. So initially they were in terms of C, then M and omega n. Now they are in terms of zeta and omega n. So these S1 and S2 values will be required for the further derivations.